Hello, good afternoon. I'm going to talk about the work that my advisors, María Ángeles Serrano and Marian Boguña and I have been developing lately about prime numbers mainly. But let me first introduce a few concepts. Well, we all know what prime numbers are. They're simply natural numbers. Those are the ones we use to count, whose only divisors are themselves in unity. And they are very important because, according to the fundamental theorem of arithmetics, every natural number greater than 1 can be factorized, that is, decomposed uniquely as a product of primes. For instance, 12 is 2 times 2 times 3, and there is no other possibility. So, in a sense, we can regard primes as being the atoms of mathematics, those fundamental pieces that we put together to form other numbers. But the thing is that the distribution of the primes amongst the integers, that is, what natural numbers are primes and which are not, is one of the greatest mysteries ever. And to see why, we only have to look at the gaps between primes. That is, the difference between them. For instance, between 2 and 3, that's simply 1. Between 3 and 5, that's 2, and so on. That's easy. But if we plot the gaps for many primes, the picture looks like this. And as you can see, there is no clear pattern here. There is no regularity. This looks very much like random, doesn't it? Well, it actually is random. It has the mathematical properties of a random distribution. But that makes no sense. We're not talking about tossing coins here. We're talking about multiplying numbers. That's perhaps the most deterministic thing we can think of. Well, quoting the British mathematician R.C. Vaughan, it is evident that the primes are randomly distributed. But unfortunately, we don't know what random means. That's a very deep thought. It's not far from philosophy, actually. And that's a great mystery. So, how is it possible? Where does this sort of randomness arise from? I believe it's a matter of complexity. That is, that the basic rules of arithmetics that we learn at school when we're little children exhibit such a complex behavior that we cannot distinguish it from actual randomness, if that exists at all. So, it seems natural to me to face the study of the primes from a perspective of complexity. And that's what we have done. We have represented the natural numbers as this network, in which we have separated primes, the green squares here, from composites, the yellow circles. And we have then connected every composite to all its prime factors, as many times as the prime divides the composite. For instance, looking back at 12, you see there are 2 connections reaching 2 and only 1 reaching 3. Well, it turns out that the proper study of these particular networks has provided a lot of information about the primes. On the one hand, we have discovered a whole set of arithmetic functions that tell us many things about how the primes divide the composites. For instance, it's been really easy to rederive the Hardy-Ramanujan theorem that tells us approximately how many prime numbers divide composites. On the other hand, we've been able to develop a parameter-free stochastic model. Stochastic model means that it's actually random. We actually toss a coin here, with no parameters. That means that we don't have to tune it, adjusting some number for it to work better. It just works as it is. And it reproduces exactly the same network that I presented to you. And what's the point in having that? Well, suppose you don't know something about the primes. Well, we don't know anything about the primes, more or less, but suppose you have a particular question about them. And you cannot answer it because the primes are so difficult. But you just go to the stochastic model, do some probability calculations, that it's quite easier, and then once you have the answer, you just guess that the answer is also valid for prime numbers. So it's a very powerful tool to conjecture and to understand what is happening, actually. And, well, we have actually improved Cramer's conjecture about the gaps between primes with that model. And last, but not least, this provides us with a new way to look at numbers that I would like to share with you. Those are prime numbers. Thank you very much for your attention.